all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. Today, in this video, let us see about clipper circuits. So, clipper circuits are the circuits that clip off or removes a portion of the input signal without causing any distortion to the remaining part of the waveform. These are also known as clippers, clipping circuits, limiters, slicers, etc. Clippers are basically wave shaping circuits that control the shape of an output waveform. It consists of linear and non-linear elements but does not contain energy storing elements. So clipper circuits are basically termed as protection devices, as electronic devices are voltage sensitive and voltage of large amplitude can permanently destroy the device. So in order to protect the device, clipper circuits are used. The basic operation of a diode clipping circuit is that the forward biased condition, the diode allows current to pass through it, clamping the voltage. But in reverse bias condition, no any current flows through the diode and thus the voltage remains unaffected across its terminals. So these are the different classification of clipper circuits. So clipper is classified into series clipper and shunt clipper. Under series clipper, we have positive and negative clippers with and without biasing. Similarly, under shunt clippers, we have positive and negative clippers with and without biasing. So now we will see each and every type in detail. So first we will see about series positive clipper circuit. As shown in the diagram, the diode is connected in series with the output, thus it is named as series clipper. So the positive half of the input waveform reverse biases the diode, thus it acts as an open switch and all the applied voltage drops across the diode, resultantly providing no output voltage for positive half of the input waveform. For the negative half of the input waveform, the diode is forward biased, so it acts as a closed switch causing no voltage drop at the diode. So hence the input voltage will appear across the resistor, ultimately at the output of the circuit as shown here. Next one is series negative clipper circuit. So here during the positive cycle, the diode becomes forward biased, which ensures the closed circuit. So the current appears across the resistor of the circuit in the positive half cycle. Whereas in the negative half cycle, the diode becomes reverse biased, which acts as an open switch. So no current will flow through the circuit. So we will get the output waveform only for the positive half cycle. Next one is a series positive clipper circuit with bias. So here we have a positive bias and negative bias. So in the positive bias, we can see that the diode is forward bias condition concerning the battery. But positive half of the input waveform puts the diode in reverse biased condition. So this diode will conduct until the supply voltage is less than the battery potential. As battery potential dominates the supply voltage, the signal appears at the positive half of the output waveform. But as the supply voltage exceeds the battery potential, the diode is now reverse biased. Resultantly, no further current will flow through the diode. Negative half of the input waveform, the diode is forward biased concerning both supply voltage and battery potential. Hence, we achieve a complete negative half cycle at the output waveform. Next, in the case of negatively biased circuit, the diode is reverse biased due to both the supply voltage and the battery potential. So this cuts off the complete positive half of the waveform, input waveform. But during the negative half cycle of the waveform, the diode is in forward bias condition due to the supply voltage and reverse biased by the battery potential. So initially when battery dominates the supply voltage, the diode is in reverse biased condition. But as the supply voltage becomes greater than the battery potential, the diode will automatically come to forward bias condition. Thus the signal starts to appear at the output. Next one is series negative clipper circuit with bias. So whenever there is a need to clip or remove a certain portion of the negative half of the input waveform, the series negative clipper circuit with biasing is needed. So here first we will see positive bias circuit. So in the positive half of the input waveform, the diode becomes forward biased. However, the battery potential causes the diode to be at the reverse biased condition. So in the beginning, the battery potential is higher than the supply voltage, so causing no current to flow through the circuit at that time. But when the positive half supply voltage exceeds the battery potential, then diode becomes forward biased and starts conduction. Hence the signal appears at the output. So during the negative half of the input, it causes the diode to be in the reverse bias. At the same time, applied potential of the battery also reverse biases the diode. So thus no signal is achieved at the output in such a condition as shown in the output waveform. Next one is a negative bias circuit. So here as shown, the positive half of the input cycle, the supply voltage and the battery potential both will cause the diode to be in the forward biased condition. Thus, complete output of the positive half is achieved. But in the case of negative half cycle, the diode is reverse biased. At the same time, due to the battery potential, the diode is forward biased. So, until the battery potential is greater than the supply voltage, current flows through the circuit. Hence, we will achieve an output as shown here. So, but as the supply voltage becomes greater than the battery potential, the diode will now become reverse biased and hence conduction stops. Ultimately, no signal appears for that portion of the input waveform at the output. Next one is shunt positive clipper. So here the diode is connected in parallel with the load, hence its working principle is exactly opposite to that of the shunt clippers. In shunt positive clipper, the output signal is observed only when the diode is reverse biased. During the positive cycle, the diode is forward biased, due to which the current flows through the diode. Hence, due to the parallel combination of diode and the load, no current is observed at the load. Resultantly, no output waveform for the positive half is achieved. During the negative half, the diode gets reverse biased, thus no current flows through it and the output current is observed at the load. So, for negative half of input, the entire negative half appears at the output. Next one is shunt negative clipper circuit. So here due to the positive half of the input, the diode gets reverse biased, thus no current flows through it and the output is observed. During the negative half, the diode gets forward biased and hence no load current is achieved. Ultimately, no output is observed. Next one is shunt positive clipper circuit with bias. So here again we have a positive and negative bias case. So in the positive bias case, during the positive half of the cycle, the diode gets forward biased, but at the same time battery potential causes the diode to be at the reverse biased condition. Until the battery potential is greater than the supply voltage, the reverse biased diode by the battery potential does not allow the flow of current through it. Hence, current flows through load and the signal is observed at the output. But when the input voltage increases more than the battery potential, the diode becomes forward biased due to the supply voltage, hence allowing current to flow through the diode and no output is achieved. During the negative half cycle, both battery and supply voltage reverse biases the diode, hence we get a complete negative half cycle at the output. So in the case of negative bias circuits, during the negative half of the input cycle and the applied battery potential both causes the diode to be in the forward bias condition. Thus the current flows through the diode and no signal is observed at the output. During the negative half of the input cycle, the diode is reverse biased due to the supply voltage but is forward biased due to the battery potential. Hence the output will not appear at the load until battery potential is higher than the supply voltage. As the supply voltage exceeds the battery potential, the diode stops conduction due to the reverse biased condition. Hence signal appears at the output. Next one is similarly shunt negative clipper. So with positive and negative bias. So with positive bias, during the positive half the diode will get reverse biased, but the battery potential will make the diode to be in the forward biased. So till the battery potential is greater than the supply voltage, the diode conducts due to forward bias. But once the supply voltage exceeds the battery potential, the diode stops conducting. Due to the negative half, the diode gets forward bias because of the battery and the supply voltage, hence no output signal is achieved. In the negative biased case, in the positive cycle, both diode gets reverse bias due to the battery and supply voltage. So we have complete positive half of the input signal at the output. During the negative half, the input cycle, the diode gets forward bias due to the supply voltage but is reverse biased by the battery potential. Thus the output signal is achieved until the battery potential is higher than the supply voltage. As the supply voltage exceeds the battery potential, the diode completely starts conduction and the signal does not appear at the output. Next one is dual clipper circuit. So whenever there is a need to remove a certain portion of both positive and negative half of the signal, then dual clipper circuits are used. Hope you understood different types of clippers. So these clippers are used in numerous applications such as transmission, in overvoltage protection, in the modification of input waveform, in voltage limiting, etc. So let us take up some assessment questions. Which circuit is used for obtaining desired output waveform in operational amplifier? Answer is clipper. In a positive clipper, the diode conducts when Vin is equal to V reference. What happens if the input voltage is higher than the reference voltage in the positive clipper? So the output voltage will be equal to the reference voltage. Thank you for watching this video.